Using the supermesh approach, find the current through each resistor. So our target is to find out what is the current that pass through this 4 ohm resistor, 6 ohm resistor, 8 ohm resistor, and 1 ohm resistor. But then we are asked to use supermesh approach. Okay, why we need to use supermesh? Because we have this current source here, 3 ampere. If we use normal mesh analysis, we need sum of the voltage. And the problem is we cannot know the voltage across this 3 ampere current source. So we need to do super mesh. But then let's do it step by step. The first one will be label all the loops. So I will have to label all the mesh or the loops in the circuit, and also extract all the available information. Okay, let's see what can we do from here. Let's start from this node here. Okay, and I will name this node here as I1. And then the second node here, we will have this one here. And I will name this node here as I2. But then I also have this node here, which is I3. Okay, but then right off the bat, we know that I2 here is the current that supplied by this 8 ampere current source. So we know exactly that I2 is 8 ampere. I2 is exactly 8 ampere. Good. And here is the ground. So we know that the voltage here will be 0. So we'll have P here is equal to 0. I don't know whether this is useful or not, but that is one of the information that we can extract from the circuit. Okay. And I think that's all that we can do. And because this one here, we cannot do KVL at I1 and I3. Why? Because we need the voltage in this 3 ampere current source. So we need to combine I1 and I3 into one single super loop. So I will have this one here, the purple one, like this. So we will have this one here as our super mesh or super loop. Okay. And now let's do the second step, which is do the Kirchhoff voltage law or KVL for each unknown loops. Okay, the unknown loops is I1 and I3, but we cannot do KVL at these loops here because of this 3 ampere current source. So the only thing that we can do now is to do KVL at the super mesh. So let's do exactly that, KVL at super mesh. Okay, KVL said that the sum of the voltage in a loop will equal to 0. Good, but we have to be careful about the sign here. Okay, let's start from this 20-volt battery here. And here the current is flowing from the negative terminal here to the positive terminal. Because the current flowing from the negative terminal, we will have negative sign. So I will have minus 20. Good. And then we will have this 4 ohm here. But then we need voltage. We need to multiply it by the current. Which current? This internal current here, which is I1, not the super loop, but the internal one. So I will have I1 here. Then let's move on to this 6 ohm resistor. I will have 6. Again, we have I1 here. So we will have I1. But then here, I2 is flowing to the opposite direction. So I subtract it with I2. But I2 is 8. So I can write 8 here. Good. Now let's move on to this one here. So I will have That one here is 8 ohm. So I will have 8. But then the current that passed through it is I3 here. So we'll have I3. But then here I2 is flowing to the opposite direction. So I subtract 8 from it. Good. And then what else? This 1 ohm. So I will have plus 1. And the only current that passed through it is this I3. So I'll have I3 here. And I think that's all for this super mesh. We have all the term, right? This one, 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5. Yeah, all 4 terms, all 5 terms. And all of that will equal to 0. Good. Now what can we do? We can do mathematics, of course. So let's do exactly that. We'll have minus 20. And then we will have 4 plus 6. That will be 10. I will have 10I1 here. And also I will have 6 multiplied by minus 8. That will be minus 48. Good. And then this one here, I will have plus 8I3. So I will have 8I3 minus 64. Right? And then I will have 1 multiplied by I3 is just I3. Good. All of that will equal to 0. And I will have 10I1. So 10I1. And then what else? Plus 9I3. Plus 9I3. And that will equal to, let's move all of that to the right hand side. So I will have 20 plus 48 and then plus 64. And I'm too lazy to calculate all that. Let's use calculator here. So I will have 20 plus 48 and then plus 64. That will be 132. So I will have 10I1 and then plus 9I3, and that will equal to 132. So I will have this one here from the super loop, 10I1 and then plus 9I3, and that will equal to 132. But then we have only one equation, but we need two, right? Because we have I1 and I3. And that is why we need the third step here. Do KCL at the branch, at the nodes with current source. Okay, let's do exactly that. Okay, probably I need to clean up this first. Okay, let's see here. What can we do from here? I think I will use this node here, right? Okay, this node here, let's name this node as A. And this node here, I3 is the only current that goes into this node here, right? So we will have this is I3. But then I1 is the one that goes out from this node. So I will have that current there is equal to I1. And here we will have the current that goes through this 3 ampere current source. So I will have this one is equal to 3 ampere. We can do KCL at node A, right? So we will have KCL at node A. Okay, KCL said that the sum of the current that goes in is equal to the sum of the current that goes out. Let's see here, the only current that goes in is I3. So I will have I3 there. And then that will equal to the current that goes out. I will have this one. So I will have 3 ampere. And then this current here, I will have plus I1. But then I can move this I1 to the left-hand side. So I will have minus I1 plus I3. And that will equal to 3. So we have our second equation here, which is minus I1 and then plus I3, and that will equal to 3. We have two equations and two variables. We should be able to solve the equation, right? So we need to solve the equations. Okay, and maybe let's do something that maybe you don't know yet. So I will use calculator. Why? Because usually in circuit analysis class, you can bring calculator into the exam. So why not just use that for calculating this? It's much faster than elimination and substitution or Cramer's rule. So let's get our calculator and set this up here as equation solver, which is number 5. Okay, two variables is number 1, and then we will have 10 as the coefficient of I1, and then 9 as the coefficient of I3, and then 132 as the result. Okay, and then the second one I will have minus 1, and then 1, and then also 3, and the x value will be I1. So this is 1, so I will have I1 is 5.526. Okay, so we'll have I1 there. So we will have I1, or probably I will write it here. I1 here is equal to 5.526. 5.526, and the unit here will be in ampere. And then what is I3? I3 will be the Y value, right? So we will have 8.526. So I'll have 8.526 ampere. But that is not the question is asking us. It is asking about the current that through each resistor. So the last step will be answer the question. Answer the questions. Let's do exactly that. But let's clean this up first. So the first thing that we have to look out is the current that pass through that 4 ohm resistor, and that will equal to I1. But we know exactly what I1 is, which is that one. So I'll have 5.526 ampere. Then let's move on to the 6 ohm resistor. So I will have I at the 6 ohm resistor, and that will be I1 here minus I2, right? Which is larger, I1 or I2? I2 is larger, and I think I will use that. So I will have I2 minus I1. Yeah, I2 minus I1. So we will have 8 and then minus 5.526. And I think this is the job of our calculator. So we'll have 8 minus 5.526, and that will be 2.474. So I will have 2.474 ampere. And this is to the left, right? Because I2 is larger here. And here maybe upwards, right? And then what is the value of this current that pass through that 8 ohm resistor? Okay, so I will have I2 and I3. I3 is larger, so I will have I3 minus I2. So we'll have 8.526 minus 8, and that will be 0.526 ampere, but the direction is to the right, right? Because I3 is larger. So I will have this to the right. And then what is the current that pass through this 1 ohm resistor? That will equal to I3. and we know exactly what I3 is, so I will have 8.526 ampere, and this one will be to the bottom. Okay, and I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.